Nations have always competed for supremacy. These days, the competition has moved into space exploration. The race is on as to which country can build the biggest and most powerful rocket ever. What nobody is ready for is the new rocket that China is unleashing on the space industry. It has just unveiled a new 800 meters tall rocket that is unlike anything ever built. What does China's new rocket offer? How will it be built? And what does China hope to achieve with it? What is the biggest rocket ever created? The award goes to a spacecraft still under development, the Starship. The spacecraft being developed and tested by SpaceX stands at 120 meters when assembled and is 9 meters in diameter. Thanks to a set of more than 30 rocket engines, the Starship can produce enough thrust to lift about 150 tons of payload to orbit at once. However, you may be surprised to learn that the first rocket to reach space officially was made by the Germans in 1944. It was the V2 rocket which crossed the Kármán line, a point defined by the Fédération Aéronautique Internationale as where space starts. But after World War II, the V2 production fell into the hands of the US, the Soviet Union, now Russia, and the UK. Over the next few decades and the start of the Cold War, what started as a nuclear arms race of superior ballistic missiles turned into a space race. Both the US and the USSR tried to be the first to achieve and master spaceflight, driving the production of many new and different rockets. However, the US got the upper hand and was producing different rockets. The eventual breakup of the USSR in 1991 transferred the production of Soviet rockets to Russia or Ukraine. And later, both Europe, using the European Space Agency, and Japan accelerated their rocket design and development as well. But more countries have now started competing seriously in the space race, including Iran, India, and China. China actually started researching rocketry before the launch of Sputnik in 1957, but it was not until 1970 that the country launched its first satellite into orbit. Since then, China's launched more than 400 missions, and almost all of them have used the Long March or Changzheng family of rockets. The first rocket in the family of Long March rockets was the Long March 1. It is a 98-foot or 30 meters long 3-stage rocket. China launched it successfully from Jiuquan in the Gobi Desert, where it took China's first satellite, Dongfang Hong-1, into orbit on April 24, 1970. It made China the country to launch its own satellite, and that day is now marked as China's annual Space Day. China also has the Long March 2C, which is 40 feet or 12 meters taller than its predecessor. It could launch 8,490 pounds or 3,850 kilograms to low Earth orbit. The rocket has been launched more than 50 times since its debut in 1982. Other Chinese rockets include the Long March 2E with 4 side boosters and 3 stages, which can put up to 7,700 pounds or 3,500 kilograms into geosynchronous transfer orbit. The Long March 5B, designed specifically to launch China's 3 large, roughly 48,500 pounds or 22,000 kilograms space station modules into orbit from a specially built spaceport on Hainan Island. The Long March 7 2-stage rocket that launched the Tianzhou cargo spacecraft weighing 29,800 pounds or 13,500 kilograms to the Tiangong space station. The Long March 9, which is the Chinese version of NASA's Space Launch System, which will help in assembling the joint China-Russia International Lunar Research Station. It has a payload capacity of up to 330,000 pounds or 150,000 kilograms. The Long March 11 is different from the rest because it's a solid propellant rocket. Since it uses solid fuels, it does not require separate tanks for propellant and oxidizer, making it simpler and cheaper. This rocket is 68 feet or 21 meters tall and can launch at sea. Despite the achievements China has recorded in its space program, it continues to dream big, and its next rocket shows it's not afraid to take on other spacefaring nations like the US. In fact, Beijing has made space exploration a top priority to be able to compete. China is currently barred from using the International Space Station, so it's building its own space station, built to last at least 10 years in orbit. It has already sent 3 astronauts to the station. However, nothing China has done in space yet compares with the next Chinese rocket. It's a huge 800 meters tall rocket that dwarfs everything before it. Actually, it's not surprising that China is building a rocket this huge. The country is home to numerous mega projects, from the most extensive bullet train to the most audacious road projects and skyscrapers built in a matter of days. To many people, this project might sound like science fiction. The very idea of building and putting a structure that is almost a kilometer long in space may sound preposterous. However, former NASA chief technologist Mason Peck warns that China should not be taken as joking. Peck said that the idea isn't entirely off the wall, and the challenge is more a question of engineering than fundamental science. I think it's entirely feasible, Peck, now a professor of aerospace engineering at Cornell University, said. I would describe the problems here not as insurmountable impediments, but rather problems of scale. It's important to put China's ambition into perspective here. The International Space Station, one of the most iconic inventions by humans, measures only 109 meters, and it was a collaborative effort between multiple countries. In fact, it unites two perennial foes, the US and Russia. And speaking of cost, the ISS gulped about $150 billion. Imagine what China's 800-meter spacecraft will cost. The ISS required 30 missions to assemble all the modules, stretching over a decade. For China, this is a long-term play and something that will give the country's program a sense of purpose for years to come. Many Western observers may mistakenly dismiss this idea as propaganda, but that will be a huge mistake. China published a report in 2009 called the Roadmap 2050, which outlined how it would become the world's leading spacefaring country by 2050. So we are witnessing China gradually implementing its space plan. One crucial question is, can China pull this project off? Actually, it is difficult to say no. Look at the recent achievements the country has notched in space. It has returned lunar rock samples to Earth for analysis, making it the third country behind the USA and Russia to do so. It has also landed its own rover on Mars, a feat that only the USA could boast of. China also pulled off the world's first landing on the lunar far side. As mentioned earlier, China is now building the Tiangong space station, which is already being inhabited and rivals the aging ISS. All this points to a country super serious about its space ambition. Looking at China's plans critically, there are several advantages to building a spacecraft as massive as it is planning. For example, such a huge structure would allow China to introduce artificial gravity, which will help astronauts escape the debilitating effects of weightlessness, such as muscle mass and bone density losses. With such a vast structure, the spacecraft can spin to produce centrifugal force and, at the right speed, can create a force that mimics the effects of gravity. However, you can't just rotate an object containing humans, because if you spin faster than a couple of revolutions per minute, the average person will start to suffer from motion sickness. However, as experiments have shown, these effects virtually disappear at rotation rates of 1 or 2 revolutions per minute. So how large would China's new spacecraft have to be in order to create Earth's gravity by spinning at a leisurely 1 to 2 RPM? It has to be about a kilometer across. This shows that China has done its homework well. So how will China get such a colossal spacecraft to space? The country can launch numerous components to space using many missions, like how it was done with the ISS, and then assemble them in space. However, there is another novel approach that China can use. Thanks to unique material, it may soon be possible to build a vast structure that can fold or collapse to fit into the nose cone of a single giant rocket, like the Starship, for instance. After being launched to space, the structure then expands. The secret to this idea is something known as mechanical metamaterials. These use joints that act like a scissor to fold down to a fraction of their deployed size. The most familiar example of such a mechanical metamaterial is the Hoberman sphere. This child's toy resembles a small spiky ball in its resting state, but can expand into a larger sphere many times its original diameter. It may sound like science fiction, but so does China's plan itself. Let's hear what you think of China's spacecraft in the comments section below.